2.4602 alloy, with the EN designation NICR 21MO14W and UNS number N06022, is commonly referred to by trade names such as Alloy C22 and Nicrifer 5621 HMO. It is a low-carbon, low-silicon nickel-chromium tungsten superalloy, belonging to the high corrosion-resistant nickel-based alloy family, widely used in harsh industrial environments. Its chemical composition is dominated by nickel, which accounts for the balance, at least 56% by weight. Chromium content ranges from 20.0% to 22.5%, molybdenum from 12.5% to 14.5%, and tungsten from 2.5% to 3.5%. These main alloying elements work synergistically to ensure the alloy's excellent corrosion resistance and structural stability. Iron content is between 2% and 6%, while cobalt is limited to no more than 2.5%. To ensure its corrosion resistance and weldability, impurities are strictly controlled: carbon less than or equal to 0.015%, silicon less than or equal to 0.08%, manganese less than or equal to 0.5%, phosphorus less than or equal to 0.025%, sulfur less than or equal to 0.015%, and vanadium less than or equal to 0.35%. Precise element control achieves an optimal balance of performance. In terms of physical properties, the alloy has a density of 8.69 g/cm superscript 3, a melting range of 1325 to 1370 degrees Celsius, and a thermal conductivity of 10.1 W/mK, at 20 degrees Celsius. Its electrical resistivity is 1.14 μ/m, and the coefficient of thermal expansion between 20 to 100 degrees Celsius is approximately 12.4 μm/m degrees C. The modulus of elasticity is 205 GPa, and the Poisson's ratio is 0.30. Mechanically, in the annealed state, it has a tensile strength of greater than or equal to 690 MPa, a yield strength of greater than or equal to 310 MPa, and an elongation of greater than or equal to 40%. The Brinell hardness is around 210 Hb, and the Rockwell-B hardness is approximately 92 HRB. It exhibits excellent weldability, with no grain boundary sensitization, ensuring stable corrosion resistance in the heat-affected zone. The core advantage of 2.4602 alloy lies in its outstanding corrosion resistance, performing stably in both oxidizing and reducing environments, and resisting pitting and crevice corrosion effectively. Compared with other nickel-based alloys, it has better adaptability to chloride-containing environments and is not prone to stress corrosion cracking. It complies with international standards, ASTM B575 for plates, ASTM B574 for bars, and ASTM B622 for pipes. It also meets NACE MR0175 requirements for acidic service environments. The heat treatment process is simple, annealing at 1150 to 1200 degrees Celsius, followed by water quenching to ensure optimal corrosion resistance and mechanical properties. Typical applications include chemical processing equipment, reactors, heat exchangers, pipelines and valves, energy sector, flue gas desulfurization systems, nuclear power cooling equipment, and marine engineering, seawater desalination components and offshore structures. It is the preferred material for harsh corrosion environments requiring high reliability and long service life.